Ibon. Today I am going to discuss about the module C, basic theory about the microprocessor. Now these are the objectives. Today I am going to discuss. These are the objectives. Briefly describe historical development of a microprocessor. Historical background. Second one, sketch a block diagram to show basic internal architecture of a microprocessor. Number 3, briefly discuss the purpose of each block comprising the internal architecture of a microprocessor. These are the objectives. Then the history of microprocessor. I think do you like to learn about the historical background about the microprocessor? For the evaluation of the Intel series. Intel is a popular manufacturer. Intel series application various computer system that the 4004, it is 4-bit microprocessor. First developed for use in calculators. At the beginning, not use personal computers, only to use calculators such as scientific calculators. And then for the development, then the 8086, it is 16-bit data bus replacement for 8088 used in IBM. I told the IBM for the development of the microprocessor. Then another company, Motorola series, different programming philosophy. They have different philosophy of the programming. They are developed. These are the briefly as follows. 68000, it's a 8-bit data bus, a popular version. 68000, 16-bit to 32 data, 16 megabyte memory. First Apple Macintosh computer. And another series for the Z80, and 6502 MOS technology, 8-bit device based on 68000 used in Apple II computers. These are some briefly I will discuss about it. Do you have any spare time? You can find out the historical background. It is important to understand about the microprocessor. Then the microprocessor construct with MOS device, which limits their operating speed. What is MOS device? MOS device, do you know the metal oxide semiconductors? For MOSFET, it is like early type operate between 1 megahertz to 4 megahertz. Earlier beginning 1 megahertz to 4 megahertz. And each new generation of microprocessor features high operating speed. I can give a example for 8486. This microprocessor operate 50 megahertz. 50 megahertz. Current microprocessor can handle 32 bits at a time. They can address huge range of memory in gigabytes and operate very high speed. For the briefing about them. Earlier I told that the microprocessor is a very important part of the microcomputer, that the brain and heart of the every computer. Now we are going to proceed to internal block diagram of the microprocessor. This is the internal block diagram about the microprocessor. Look at thoroughly. You can look at this picture, and I'll show this basic block diagram, internal architecture about the microprocessor. Internal architecture about the microprocessor. And internal architecture of all microprocessors are different. That is very complicated thing. That therefore, do you remember that the architecture about the all microprocessors are different, but basic blocks shown in this picture. Only basic blocks. Do you remember that the basic blocks are shown in this picture? Are included in all of them. These blocks are as follow. At the beginning, that the buffer, there are two places we are mentioning this buffer. This is the buffer. This is the buffer. This place buffer. You can mention those things. Buffer. What is buffer? To interface the addresses and data bus to the microprocessor. Buffer. That the interface that the data bus are bidirectional. This arrow shows us. This is unidirectional in say one direction. Addresses bus. This addresses bus. Then the microprocessor can be function only binary data like hexadecimal, octal, and 10. This is the buffer for the then correct voltage levels and finding. And buffer. Now the second one, internal bus. These are the internal bus. Internal bus all enter to ALU circuit, accumulator, status register, general purpose register, stack pointer, program counter, buffer, and instruction decoder and controller. These are the internal data bus. Internal bus. To link each block within the microprocessor. Link. Let the bus system link to each of the blocks. Then is the data bus, internal bus. These are the internal bus. To link each block to each block within the microprocessor. Then the ALU circuit. This is the ALU circuit. ALU circuit perform arithmetic logic unit. It is a arithmetic logic unit. perform mathematical and logical operation. The mathematical and logical, any logical operation can be create this block, and also logical operations, and this finish. And the accumulator, is the accumulator work with ALU. When the result of the ALU, then temporarily store the accumulator. For the mathematical law and logical operation, temporarily store the accumulator. Then the status register. Status register is there. Status register give information about the result certain operation. Give information about the result of certain operation. Certain operation means that the logical law, mathematical operation. Status register is there. And the general purpose register. This is the general purpose register. This block shows general purpose register. Its main function, temporary data storage. And finally, stack pointer. This is the stack pointer. Stack pointer hold address of the particular section. Address about the particular section of the memory used for certain operation. It hold, remember, and keep for the future operation. Hold the address of the particular section of the memory used for certain operation. Instruction register. This is the instruction register. Store instruction when the fetch from the memory. Instruction register fetch from the memory. Do you always think about this microprocessor in the motherboard? There are several other components in the motherboard, that the RAM and lot of other components. Only to mention the block for the microprocessor. Instruction register store instruction when fetched from memory. Last one, instruction decoder. Instruction decoder and control decode current instruction and set or respond to the control input output. It is also connected at the instruction decoder, also connected to the control bus. This is a bidirectional. This is briefing about the microprocessor function. Now I will going to tell all of buffer. You can note down buffer to interface the addresses and data bus to the microprocessor. Second, another one, internal bus to link each block within the microprocessor. Link. ALU, arithmetic logic unit, perform mathematical and logical operation. Accumulator, this is the accumulator. Work with ALU. Program counter. This is the program counter. Hold the current address on the address bus. Hold current addresses on the address bus. stack pointer, hold the address of particular section of the memory, use certain operation. Instruction register. Instruction register store instruction when the fetch from memory. Instruction decoder and control. Decode current instruction and set or respond to the control input output. These are the function about the microprocessor in brief. And that the basic operation. This microprocessor essentially programmable logic device. Do you remember? It's a programmable logic device. Another chapter we will discuss about how to program the microprocessor. That it is perform a function determined by the binary code applied to its input. The binary code is a series of instructions from the program stored in memory. Basic instruction cycle of a microprocessor: fetch and execute cycle. Now we want to know the fetch cycle and execute cycle. It's the very important to understand the cycle. That the fetch cycle and execute cycle in this picture. Or what is meant by fetch cycle and execute cycle? It is a basic operation cycle of a microcomputer. This is the basic cycle of the microcomputer. Basic cycle. It's process by which program instruction from memory determine what action the instruction require. That the basic operation cycle. The memory determine what action the instruction require and carried out those action. This cycle repeated continuously by CPU, central processing unit, from boot when the computer is shut down. This is the control unit, ALU. This is a RAM. This is a RAM for the cycle. Each process instruction from memory, and then control unit decode into, then execute ALU, and then after finishing work, then stop also RAM. This cycle repeated when the computer, when it's shut down. This cycle is very important one. Today I am finishing the class. Goodbye.